Welcome to the fifth part of kinetic theory. In this part, you will learn more about degrees of freedom and law of equipartition of energy. Degrees of freedom of a diatomic gas like nitrogen, oxygen, hydrogen, carbon monoxide, etc. All these consist of two atoms fixed at a distance apart, and therefore the value of n will be 2 and number of independent relations will be 1 and their degrees of freedom will be 3n minus k, means 3 into 2 minus 1 equals to 5. At high temperature, a diatomic molecule also have two additional degrees of freedom due to vibrational motion, and each vibrational motion has both kinetic and potential energies. So 1 degree of freedom of vibrational motion is taken as 2. The diagram shows the rotational motion of a diatomic molecule about two independent axes. Let's find out the degrees of freedom for a triatomic gas. For a triatomic gas, molecules are of two types. If they form a non-linear molecule structure like water, H2O, SO2, then the three atoms are located at the vertices of a triangle. Means the value of n will be 3 and the independent relations will also be 3. So by putting in the formula of degrees of freedom 3n minus k, you will get 3 into 3 minus 3 equals to 6. But if they form a linear structure like CO2, HCN, CS2, then the atoms are arranged along a straight line and the number of independent relations between them will be only 2. So the value of k will be 2 but n will remain 3. So the degrees of freedom will be 7 in this case. A monoatomic gas molecule has only translational kinetic energy. So a monoatomic gas molecule has only 3 degrees of freedom. And in addition to translational kinetic energy, a diatomic molecule has 2 rotational kinetic energies. So the degrees of freedom of a diatomic molecule is 5. It doesn't vibrate. Diatomic molecule like carbon monoxide has a mode of vibration even at moderate temperature. Its atoms vibrate along the interatomic axis and contribute a vibrational energy term denoted by E with subscript V to the total energy, and so a diatomic molecule has 7 degrees of freedom if it vibrates. Law of equipartition of energy states that in any dynamical system, in thermal equilibrium, the energy is equally distributed amongst its various degrees of freedom, and the energy associated with each degree of freedom per molecule is half kBT, where kB is the Boltzmann constant and T is the absolute temperature of the system. Let's prove it. For this, consider 1 mole of a monoatomic gas in thermal equilibrium at any temperature T. And you know that monoatomic gas molecule has 3 degrees of freedom due to its translatory motion. According to kinetic theory of gases, the average translational kinetic energy of the gas will be half mv bar square, and that will be equals to 3 by 2 kBT. If Vx bar square, Vy bar square and Vz bar square are the components of its mean square velocity along the three coordinate axes, then V bar square must be equals to the sum of these. Means half m Vx bar square plus half m Vy bar square plus half m Vz bar square must be equals to 3 by 2 kbt. As the molecule motion is random, there is no preferred direction of motion. So the average kinetic energy of each molecule along each of the three axes will be same. So half m Vx bar square equals to half m V by bar square equals to half m Vz bar square will be equals to half kbt. Or you can say that the average kinetic energy per molecule per degree of freedom is half kbt. And this was first deduced by Boltzmann and is called the law of equipartition of energy.